Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome again to the TV learning programs. I'm Teacher Pasco, and today I will be with Senior 2 students learning chemistry. In the previous lessons, we studied unit number 6, and we specifically talked about the solubility of salts. Do you remember the meaning of solubility? Today, we will continue with the same unit, but with a new topic, calculations of solubility, or the calculations involved in solubility. There is a lot or many types of calculations we can perform involving solubility. But before we go deep into the topic, I want you to try these 2 questions of revision. What is solubility? And number 2, how does temperature affect solubility? Remember, we also discussed the factors which influence solubility. So you will explain how solubility changes when temperature is changing. You have 1 minute to think about the 2 questions. Well done. So, how have you defined solubility? If you have defined it as the amount of solute in grams that can completely dissolve in 100 grams of water at a given temperature, you are right. That is the definition of solubility. Amount of solute in grams that can completely dissolve in 100 grams of water at a given temperature. And here we are saying at a given temperature. Do you remember why we have to be very specific with that temperature? Why do we have to define temperature? I'm sure you do. It's because when temperature changes, the solubility also changes. And that will give us the answer for the second question. When temperature increases, solubility increases too. When temperature increases, more solute can dissolve. And when you reduce temperature, less solute will dissolve. So, as temperature increases, solubility increases, and as temperature decreases, solubility also decreases. Temperature decreases, solubility decreases. Now let us start our new lesson, solubility calculations. How is this new lesson related to the revision questions? In the 2 revision questions, we have defined solubility. It is saying that solubility is the amount of is equal to the mass of solute over mass of solvent times 100. Why do we multiply by 100? It's because we consider solubility in 100 grams of solvent. That is our definition. We consider solubility in 100 grams of what? Of solvent. So we take the mass of our solute over any mass of the solvent, what we have, and then we multiply by 100 to consider that solubility in 100 grams of the solvent. And as you can see, here we have mass, which will be expressed in grams, and here we also have mass of the solvent, which will also be expressed in grams, and because of that, gram and gram will cancel out, and then we have a dimensionless value, quantity, okay? So that solubility has no units. Okay, and here we said that how does temperature affect solubility? When we define solubility, we have to be very specific with the temperature because, as we know, temperature changes and also solubility changes. So when you say the solubility of a given substance is this one, it will be at a particular temperature. If you change that temperature, then you also change what? You also change the solubility. We will see that. Now, let us have a look at the first type of the calculations we can have in this unit. Question number 1, calculate the solubility of a solute Y. I've called our solute compound Y. If only 80 grams of it can completely dissolve in 200 grams of water. And remember, at a given temperature, so it is at 20 Celsius degrees. Calculate the solubility of a solute, I repeat, if only 80 grams of it can completely dissolve in 200 grams of water at 20 degrees. I want you to take like 15 seconds and think about how we can solve this question. What can we do to get this solubility? It's something very simple. Look, solubility is equal to the mass of solute over the mass of solvent times 100. And what are we asked here? We are asked to find the solubility. So from the formula, we have to check if we have everything we need. Do we have everything we need to just apply this formula? So we have to go back in the question and see if we have mass of solute and the mass of solvent. Let us analyze the question. Calculate the solubility of a solute Y if only 80 grams of it. The it we have here stands for the solute Y. So we have the mass of the solute. Mass of solute has been given. If only 80 grams of it can completely dissolve in 200 grams of water. Water is the solvent. So we have both data we need to solve our question. And the data we have here is the mass of solute, that is 80 grams, and mass of solvent, which is 200 grams. And what is being asked, the question we have is to find solubility. And what formula are we going to use? We use this formula. Solubility is equal to mass of solute over mass of solvent times 100. And then we get solubility, which is equal to try and make a substitution. We have the formula, we have the mass of solute, mass of solvent, and also the formula, as I said. So try and make this substitution and use your calculators to find the final answer. 10 seconds, please. All right. So if we substitute, we have mass of solute, that is 80 grams, over 200 grams times 100. What do we get? We have 100 and 200. We can simplify, and here it remains 2. And then 80 grams and grams will cancel out, and we get 80 over 2, and that will be 40. So the solubility of our solute Y at 20 degrees is 40. The solubility of solute Y at 20 degrees is 40. I think everything is clear. Now let us go to the second type of question. The solubility of sodium chloride is 37 at 30 degrees. What mass of sodium chloride is needed to prepare its saturated solution in 500 milliliters of water? Take 30 seconds and think about how we can work out that question. You read the question and think about how we can work out that question. And the hint here I can give you is that we use the same formula, but we have to make a rearrangement. A rearrangement. And you make the subject what you have been asked to find. That is simple mathematics. Good. The solubility of sodium chloride is 37 at that temperature. So what we have been given is solubility. Solubility, which is 37. And what mass of sodium chloride is needed? We also have the mass of solvent. Mass of a solvent is 5. Do you remember how we convert milliliters into the mass? 1 milliliter of pure water is equal to 1 gram of pure water. So if we have 500 milliliters, then we have 500 grams. I hope you remember that very well. It's just density, okay? You remember the density. So if you have density and you have volume, you can find the mass. So we have mass of solvent and the solubility. And what is the question? The question here is to find the mass of solvent. Mass of solute. Mass of solute. How do we rearrange the formula we have here to make mass of solute the subject? Think about that. How do we work out this? So solubility, which is 37, the easiest way is to use the formula and we substitute. So the solubility, which is 37, what we have here, is given by the mass of solute over 500. So this 500 is mass of solvent times 100. And what do we get from this? 100 and 500, we simplify and we get 5. So from there we have that 7, which is equal to mass of solute over 5. So if we use cross multiplication, we get mass of solute, which is equal to 37 times 5. And what is the answer? Use your calculators, please. 37 times 5, it's 185. So we need 185 grams to make a saturated solution of sodium chloride in 500 milliliters of water at exactly 30 Celsius degrees. Is it clear? Yes, it's clear. And the third question, I hope I'm not going too fast. You can follow easily. The solubility of copper sulfate at this temperature is 21. What mass of copper sulfate should be added to a solution of 250 milliliters of water and 30 grams of copper sulfate to make the solution saturated? Now we are starting with a solution. We have already prepared a solution. But as you can see from this question, the solution we have prepared is not saturated. So what we have to do is to add more solute as to make the solution saturated. But how do we know the mass we are going to add? That is the question. So to know the mass we are going to add to make our solution saturated, first of all, we have to use what we have been given and find the mass which is already in the solution. And comparing the mass which is already in the solution and the mass we need to make the solution saturated, we can find the difference. Is it clear? Yeah, it makes sense. You find the mass which is already in the solution, and remember we have solubility, and then you find the mass which is supposed to be used and make a saturated solution, and then calculate the difference. The difference is what we have to add. Let us work it out. The solubility of copper sulfate is 21. What mass of copper sulfate should be added to a solution of 250? First of all, let us find the mass that should be added to copper sulfate. The mass of copper sulfate that should be added to 250 milliliters and make a saturated solution. So we have this solute, solubility, it's 21, and we have the volume of our solvent, and from there, from the volume of the solvent, we have, of course, the mass, because we can use that density and volume to find the mass. So mass will be given by what? From the formula, mass is equal to solubility here the mass is given by, let us use the simple method. So we have our solubility, it's 21, which is equal to the mass of solute over the mass of solvent is 250 times 100. And as we said, here we have 100, here we have 250, it becomes 2.5 if we simplify, and then the mass of solute to make a saturated solution will be 21 times 2.5. 21 times 2.5 21 times 2.5, what do we get? If you use your calculator, you find that 21 times 2.5 is equal to 52.5. So this is the mass of copper sulfate. We have to add to this amount of water to make a saturated solution. And it is said that we have already a solution of 30 grams, containing 30 grams. So the mass that we have to add, mass to be added, is just the difference, 52.5 grams minus 30 grams, and we get 22.5 grams. So that is the mass we have to add to make a saturated solution. The solution we have already prepared is unsaturated. So if we have to make it saturated at this temperature, we have to add 22.5 grams. And you can see that all the calculations are simply based on this formula. The formula we also get from the definition. So it is something very simple you can deal with. And that is the reason why I'm going to give you some additional exercises. You will try, and when you will finish them, you will also try the homework. The additional exercises we have, question number 1, calculate the volume of water required to make a saturated solution of a solute X if its solubility at this temperature is 50. We know how to get the mass. We know how to get the mass of solvent. From the mass of solvent, you can determine the volume. Remember the density. And what mass of sodium nitrate is present in its saturated solution containing 300 grams of water if its solubility is 8 at 20 degrees. Very simple. You can find the mass. That is the mass of solute. And the solubility of sodium nitrate at 30 degrees is 95. If at a higher temperature, 400 grams of water contain 395 grams of the solute, what mass will precipitate out if the solution is cooled down at this temperature? This is almost the opposite of what we have here. So here we have a supersaturated solution, but here we had an unsaturated solution. So here you will find the mass that will be removed when the solution will be cooled down. And now the homework. The solubility of sugar at that temperature is 40. How many grams of sugar are needed to make a saturated solution of 1 liter of water? It's very simple, just like this first question. And number 2, 7 grams of a saturated solution of a salt at 60 degrees is evaporated to dryness. What is the solubility of the solute at that temperature if the white residue has 2 grams? You will remember to distinguish the mass of solute and mass of solvent. And the last, the solubility of a solute is 20 at 40 degrees. What volume of water is needed to make a saturated solution of 100 grams of solute? That is very simple. So you will refer to the examples I've given and try to adapt the methods used to work out the exercises and the homework. You will do it, I'm very sure. So let me close the lesson from here and thank you for your attention and hope to see you next time. Thank you very much.